Before the James Webb Space Telescope, our furthest glimpse into the cosmos stopped at GNZ 11, a galaxy discovered thanks to the powerful eyes of the Hubble Space Telescope. Hubble's 2.4-meter mirror and refined optics stretched the boundaries of what humanity could see, but even its impressive capabilities had a limit. Then, everything changed. The James Webb Space Telescope launched a new era. With its massive 6.5-meter gold-coated mirror and infrared precision, Webb wasn't just an upgrade, it was a revolution. It didn't merely continue Hubble's legacy, it obliterated previous records. One of its early victories came with the discovery of jwst 13, a galaxy with a redshift of 13.2. Soon after, another pushed even further, jwst 14 with a redshift of 14.32. In cosmic terms, that meant we were now seeing light from when the universe was just 300 million years old. But the real shock was yet to come. Introducing MOMZ 14, redshift 14.44, distance, the furthest confirmed galaxy ever seen. But distance wasn't what stunned astronomers. It was what this galaxy looked like. MOMZ 14 is tiny, only about 500 light-years across. Compare that to the Milky Way's 100,000 light-year sprawl, and it seems almost microscopic. But despite its size, MOMZ 14 is blazing with starlight, radiating the intense energy of countless newborn stars. Most early universe galaxies are dim, barely detectable. This one is a cosmic furnace, a furious star-making machine at the dawn of time, and yet, something was missing. There was no sign of a supermassive black hole. That's strange. Galaxies that form stars this rapidly usually host a monster at their core, black holes that shape galaxy evolution, regulate star birth, and stir the dynamics of cosmic structures. MOMZ 14 defies that rule, but the mystery deepened. When Webb's spectrograph dissected the galaxy's ancient light, scientists found something even more unexpected: high concentrations of nitrogen. Nitrogen? That's not something you'd expect in such a young galaxy. Nitrogen is forged in stars and scattered across space when those stars die. Its presence in MOMZ 14 suggests multiple generations of stars had already lived and died before this galaxy even formed. In short, MOMZ 14 shouldn't exist. It's too small, too bright, too chemically rich, and too early. This challenges everything we thought we knew about the early universe. According to our current models, galaxies back then should be few, faint, and simple, mostly made of hydrogen and helium. MOMZ 14 tears that rulebook apart. And it's not alone. Dozens of similar galaxies, nicknamed little red dots, are starting to appear in Webb's deep field images. They're bright, they're early, and they're far more common than we ever imagined. Galaxies like MOMZ 14 are rewriting cosmic history. What if the early universe wasn't slow and simple? What if it was fast, furious, and chemically complex from the start? MOMZ 14 could be just the beginning. In the coming years, the Nancy Grace Roman Space Telescope will join Webb in scanning the skies. While Webb zooms in with sharp precision, Roman will capture wide-angle views of the early cosmos. Together, they may find hundreds, maybe thousands of galaxies like MOMZ 14, each one a clue, each one a crack in the old theories, each one a step closer to answers we didn't even know we needed. For now, MOMZ 14 stands as a cosmic milestone, a glowing ember from a time when the universe was still assembling itself, still writing its prologue. And in its glow, we're seeing something profound. Maybe our models aren't broken, but maybe they're incomplete. And as we peer deeper into the past, the universe keeps whispering the same thing. You don't understand me yet. And here's where things get weird. In a universe that's truly random, you'd expect galaxy rotations to be pretty evenly split, half spinning clockwise, the other half counterclockwise. No big deal, just cosmic chaos doing what chaos does. But that's not what scientists found. Instead, there's a strange imbalance. A subtle but unmistakable preference, a cosmic bias toward one spin direction. Galaxies across vast regions of the sky are rotating the same way. It's as if the universe itself remembers a direction, like it was spun. That kind of pattern shouldn't exist, not if our current cosmological models are correct. And it's got scientists asking a truly extraordinary question. What if our universe is inside a black hole? To even entertain that idea, we need to go back to the basics. What actually happens when a black hole forms? When enough matter collapses under its own gravity, it creates a boundary known as the event horizon. Anything that crosses it, light, matter, information, is lost to the outside world forever. But what lies beyond that veil? That's one of physics' deepest mysteries. Enter a bold idea called black hole cosmology. According to a theory known as Schwarzschild cosmology, Our entire observable universe might be the inside of a black hole, one that formed in a much larger parent universe. Wrap your head around that. The Big Bang we think of as a beginning might not have been a sudden explosion from nothing, but instead, the result of something collapsing, a cosmic bounce back from the core of a black hole. That means every black hole in our universe could potentially be the womb of a brand new universe. And vice versa, we might be living in someone else's black hole right now. And here's the kicker. This idea could explain why our universe seems so finely tuned for life. According to this framework, only the black holes that give rise to stable, life-friendly universes survive long enough to spawn offspring. Over countless cosmic generations, universes evolve, just like life, naturally selecting for those that can continue. Still following? Good, because we're about to dive even deeper. Black holes aren't just dense, they're information monsters. They carry staggering amounts of entropy, and some physicists believe that might link directly to the information content of our universe itself. In a sense, the universe isn't just inside a black hole, it might be the black hole. Now consider this. In extended versions of Einstein's general relativity, like the Einstein-Cartan theory, there's more going on than just bending space. These theories introduce something called torsion, the twisting of space-time caused by particles' intrinsic spin. And under extreme conditions, like those at a black hole's core, torsion could actually create a repulsive force strong enough to prevent the formation of a true singularity. Instead of collapsing into an infinite point, the matter might rebound violently outward, a big bounce. And that bounce, it might be what we call the Big Bang. If that's true, then what we think of as the beginning of our universe was really just a continuation, a ripple in an endless chain of cosmic births and rebirths, one black hole, one bounce, one universe, again and again. But there's more. Some researchers are starting to see cracks in the long-held belief that the universe looks the same in every direction, a concept known as cosmic isotropy. Instead, we're finding hints of a preferred direction, a faint axis around which galaxies seem to align. That's called cosmic anisotropy, and it's a serious challenge to everything we thought we knew. Could this axis be the fingerprint of the universe's spin? A trace of how it was born? Maybe even a directional echo from that parent universe? And then there are the ancient giants, massive galaxies we've discovered that formed way earlier than our models say they should have. According to current theory, it should have taken billions of years for such structures to assemble. Instead, they show up shockingly early, like they were waiting at the starting line. Could all of this, galactic spin, cosmic anisotropy, chemical complexity, impossible age, be pointing towards something bigger? Maybe, or maybe not. Of course, there are simpler explanations. Some measurements might be off. Our models might need fine-tuning, not a full rewrite. Maybe the spin bias is just a statistical fluke. Maybe we misunderstood how fast galaxies really grow. But here's the truth. The universe is weirder, wilder, and far more complex than we ever imagined. These new findings, about spin, about early galaxies, about the very structure of space-time, are forcing scientists to look again at everything they thought they understood. Some of the boldest minds are now considering that we might be living inside a nested reality, a universe born in the heart of another. And if that's true, then maybe every time a star collapses, another reality begins. Thanks for watching. If your mind's still intact, don't forget to like, subscribe, and ring the bell before this video collapses into a singularity and spawns another one just like it.